So for today, we're going to talk about the details of electron configuration, particularly understanding what energy level means, then sublevel, orbital, and then the number of electrons. So I'm going to make an analogy for you to understand all these four basic terms and concepts in the way the electrons are distributed around the atom. So I'm going to draw a structure. It's like a building structure, okay? Now this building is pretty weird. This is not the usual building we see, but this is just a very direct analogy to the four terms that we need to understand for today. So it's like I am building something. My first floor is just a very simple first floor with one box, okay? My second floor will expand to two boxes, okay? So it's like an inverted pyramid. Next, when I go to third floor, my building will have three boxes, or three different units in a way, 3 units. So first floor has 1 unit only, my second floor has 2 units, my third floor has 3 units. Then I'm going to have my last floor, my fourth floor, and my fourth floor will have 4 different units. And let me label this with integer 1 for first floor, 2 for second floor, 3, and then 4 for the fourth floor. These numbers are the floor numbers if we think about it as a building. However, in terms of electron configuration, these numbers represent the energy level. So the energy level are represented by positive integers starting with 1, then 2, and so on and so forth. 1 being closest to the ground. If you're thinking of a building, in the atom, 1 is the one closest to the nucleus. So the one closest to the nucleus has a smaller space compared to the ones that are farther from the nucleus. So if you've noticed that in an atom, as we expand or increase our energy level, the wider the space gets, because you'll have a lot of units that will accommodate more electrons. So that's the concept of energy level. As the energy level goes up, more electrons can be accommodated in that space around the nucleus of the atom. So energy level will be the floor numbers, and these are represented by positive integers. The limit for now for energy levels is up to number 7. The limit, because according to the periodic table of elements, we only have up to 180, the element 118, and that is up to the 7th energy level. I will draw only up to the 4, because the 4th floor up to the 7th floor are all the same. So they have the same design with 4 different units. Okay? So that's my building and floor number. The next thing we need to learn is that in every energy level, there is what we call the sub-level. So what are these sub-levels? If you look at your notes, on these notes here, you have 4 sub-levels, and they are with letter initials, and we have it as S, P, D, and F. Let me repeat. The sub-levels have names, or the unit in a room or in an apartment has different names as well, depending on the cost of that particular unit. So in terms of the electrons can be located in a certain sub-level. And there are only 4 sub-levels present. And this is like the alphabet in chemistry. Remember these 4 letters in correct order. S, P, D, F. These 4 letters have to be written in small letters, and these letters came from the description of light emitted by the electron. So FYI, the meaning of every letter came from the description of light. So S means sharp, So S, this stands for sharp. P stands for principal. D for diffuse. And then F for fundamental. So these are the meaning. And then chemistry is always shortening things. So therefore, instead of using the words, we are just using the first letter of these descriptions of light. So that's why it's S, P, D, F. S being the first because it has the lowest energy, followed by P, then D, and then F. So remember, these are the 4 sub-levels. So when you're asked for sub-levels, only these 4 letters have to be there. So how does it relate to our building? To our building here, the SPDF are the type of units in every floor. So the first floor has only one type of unit. And among the 4 sub-levels, S is the first. So the only sub-level or the type of unit present in the first floor is just the S type. Okay? So first floor, S type. When we go to second energy level, it has S and then the second one, P. When we go to the third energy level or the third floor, it already has 3 types. We have S, P, and D sub-levels. Then we go to fourth floor, we already have the S, P, D, and then the F. Everything is there starting at fourth floor onwards. If you notice the progression of the sub-levels, we always begin with the first sub-level, which is S. Then we have SP, then SPD, and then by fourth floor, S, P, D, and F. Fourth floor until seventh floor, they're the same. It's until F, because there are only 4 sub-levels. Okay? Now, what does this mean, Ms. Narca, the sub-level? What does it do? The sub-levels will tell us, because these are like the units. How expensive are they? Like when you get into the unit, how do they look like? In a certain unit, we know that there are certain number of rooms inside a unit. So in every sub-level, let's go back to our notes. In every sub-level, we have what we call the number of orbitals. So the third term we're learning today is orbitals. Orbitals is the number of rooms in every unit. And chemists have found out that in SP, D, and F, their number of rooms are different. And they were able to find this number of rooms here. So S only has 1 orbital, 1 room. While the P has 3 rooms or 3 orbitals. Then the D has 5 orbitals. And then the F, the last one, has 7 orbitals or 7 rooms. So when we are to draw this fixed number of orbitals in every sub-level in our building, this is how it's going to look like. S has 1 orbital, so I will draw 1 red box to represent that when I get into the unit, there's only 1 room there. And so I see a lot of S here. So all the S, regardless of what floor they are, will always have 1 room only. All S's. So all S sub-level will only have 1 orbital. Next, the P. All the P has 3 orbitals based on this chart. So we have 3. I'm going to draw 3 rooms for the P. And this is also a P, so I'm going to draw the 3 rooms. And then the last P here, I'll have 3 rooms. Okay? So P will always have 3 orbitals. The next one is the D. So the D has 5 rooms. So we're going to draw 5 rooms for the D. 1, 2, 3, 4, 5. And so this one is also 5. You have 1, 2, 3, 4, and 5. So that's 5 rooms for the D. And lastly, the most expensive unit is the F level. And the F sublevel has how many orbitals? It has 7.
Miss, can you see your screen?
So that will be... Okay, so the last one that we have here is the F sublevel. The F sublevel has 7 orbitals. Therefore, we have to draw 7 rooms in our F sublevel. So that's 1, 2, 3, 4, 5, 6, and then 7. So that's 7 rooms. If you think about it as an apartment, the F sublevel is the most expensive because when you get in here, there are 7 rooms inside the unit. So it will occupy more and more electrons. Okay? So let me have a recap again. The floor numbers are the energy level. And in every energy level, you have these letters: S, SP, SPD, SPDF. SPDF are what we call the sub-levels. And in every sub-level, you have the number of orbitals that's fixed for every sub-level. 1 for the S, 3 for the P, and then 5 for the D, and then 7 for the F. That's the number of orbitals in every sub-level. The last thing we need to know is the number of electrons. Like how many people, if going back to our analogy, how many people can occupy a certain room? Here is the rule. Pauli's exclusion principle states that only a maximum of 2 electrons in an orbital can occupy in that particular room. So 1 orbital should only have good for 2 electrons. Why good for 2? Remember that if you put together electrons, they're negative. And if they're negative, they should repel. And we don't want that because the atom has to be stable. So what happens when there is a limit of 2 electrons in every box? What happens here is, because the electrons are always moving, then these electrons have to spin in an opposite direction, clockwise and counterclockwise. So when we represent the spinning, in every box there should be 2 electrons. We will draw it as arrow up and arrow down. Arrow up means counterclockwise. Arrow down means clockwise. The 2 arrows represent the 2 electrons that are spinning in opposite direction. By spinning in opposite direction, their repulsion will be minimized. Therefore, your atom is stable. That's why there's only 2 electrons, because if you have more than that, there's no more other direction for other spin. So that will be greatly impossible. So that's why in every room, it's just good for 2. So all our S, if you look at all our S, it only has 1 box each or 1 orbital. So therefore, all S should have 2 arrows up and down, to represent the max of 2 electrons in the S sublevel. So if the question will be, what's the maximum number of electrons that can occupy an S sublevel, what will be your answer? The correct answer will be 2 electrons. Let me repeat. If the question will be, what's the maximum number of electrons that can occupy an S sublevel, the correct answer will be 2 electrons. And the reason for that, it's because your S sublevel only has 1 orbital, or 1 box in this case. If we go to the P sublevel, how many orbitals does a P sublevel have? 3 orbitals. In every orbital, how many electrons again? 2. So therefore, what's the maximum number of electrons in a P sublevel? Again, there are 3 orbitals 2 electrons each, so therefore a max of 6 electrons in the P. And how do we draw that here? The electrons will be distributed this way. You put 1 electron each for every orbital. 1 each, the same direction. So 1, 2, 3. All 3 rooms have to have at least 1. Then when you want more, then you go to the first one, pair it up. 4, 5, and then 6. This is just the correct way of distributing it when you're drawing it. Okay? The same thing with the P here. That will be 1, 2, 3, and then 4, 5, 6. And we have another P in the 4th floor. That's the same. We have 1 each, and then we have 4, 5, 6. Still a total of 6. So all the P sublevel should have 3 orbitals, and because there should be a max of 2 electrons in an orbital, 3 times 2, P can accommodate up to 6 electrons, regardless of what energy level that is. Okay? Regardless, as long as it's a P. And now we can guess. If we go to the D, how many orbitals does the D sublevel have? 5. There are 5, correct. And so what's the maximum number of electrons in the D? If there are 5 rooms or 5 orbitals and 2 electrons in every room, what's the total number of electrons in the D? The maximum. That will be, let's take a look at that. That's 1, 2, 3, 4, 5. So 1 each, 5. Then we have to pair them up. That will be 6, 7, 8, 9, 10. So what's the maximum number of electrons in the D sublevel? That will be 10. The reason again, it's because you have 5 orbitals or 5 rooms, then 2 in every room. So 5 times 2, that will be equal to 10. So that will be the same for the D here. So 3, 4, 5, and then we have 6, 7, 8, 9, and then 10. And lastly, for the F, how many rooms does an F orbital have? F sublevel has how many orbitals? 7 orbitals. So therefore, what's the max number of electrons in the F? 14. That will be 14. So I'm not going to draw anymore the 14 arrows. It's going to be too tiny. You know how it means or what it means, okay? So if we go back to our notes here, you see this number of electrons already plotted for you. So that's your 2, 6, 10, and then 14. And then below your notes, if you look at this, these are our floor numbers. So if you're gonna sum it all up, if we have the first floor, we only have the S. And S has 1 orbital. And in 1 orbital, 2 electrons. And so therefore, the total electrons is also 2 for the first energy level. Okay? Then the second energy level, we already have S and P. S has 1 room, 3 rooms for the P. And so if these are the number of rooms, 1 room, 2 electrons. 3 rooms, max of 6 electrons. So 2 plus 6, that's a total of 8 electrons in the second energy level. Correct? Next, the third energy level. We already have S, P, and D. S, P, D. S has 1 room. P has 3 rooms or 3 orbitals. And then the D has already 5 rooms or 5 orbitals. So how do we get the number of electrons? 1 room, 2 electrons. 3 rooms, 6 electrons, because 3 times 2 is 6. Then 5 rooms times 2, 10 electrons. You total all of them, 2 plus 6 plus 10, that's a total of 18 electrons all in all. Is it correct? 18 for the third floor. third energy level?
Yeah, I think, yeah.
Okay, and then the fourth energy level, it has everything. S, P, D, and F. S has 1 room, P has 3 rooms, D has 5, and then 7 rooms for the F. All multiplied by 2, then you will have 2, 6, 10, and then 14. You total all of them, so you'll get 32 electrons all in all for the 4th floor or 4th energy level. It's all a total of 32. And then if you notice, for the 5th floor onwards up to 7, it's the same with 4th floor. It's all 32 onwards. That doesn't change because F is the limit. So 4th floor, 5th floor, 6th, 7th floor, all will be 32. Now, it's time for us to go to our part B here. Okay, let's see if you're able to answer this. Part B, in your chart here. What's the maximum number of electrons in a 2s? Who can tell me?
2.
That will be 2 because it's an S, so your basis is the S. How about 5P?
6.
It's a 6 because it's a P. How about 4F? 14 electrons. How about 3D? 10. How about 4D?
10.
It's also 10 because all are D. And 1S? 2. So if you've noticed, it's not dependent on the energy level, not on the floor number, but the number of electrons are dependent on the sub-level, the number of rooms. Take note of that. Okay? Any questions on the chart part? Okay, online, do we have any questions? Okay, let's go to the back part. Okay, go ahead. Number 2, what is the shape of an s orbital? If you were looking at your nearpod, the s is the simplest among the 4 sublevels. The s has only a shape of a sphere. So it's spherical in shape. Okay, spherical in shape. Number 3, how many s orbitals can there be in an energy level?
1.
There's always 1. That represents your 1 room, correct? It will always be 1 room regardless of the energy level. Next, how many electrons can occupy an s orbital?
2.
That will always be 2. 1 room, good for 2. Number 5, what is the shape of a p orbital? This was in your nearpod. To give a name to the 2 lobes, that's like the dumbbell that we use for working out. So it's like a dumbbell shape. So the p orbital, it's like a 2 lobe, just like that. So that's why it's called a dumbbell. Okay, so it's like an 8, but that's the drawing of a dumbbell. Okay, this is the drawing. Next, how many p orbitals are there? There will always be 3. What is the lowest energy level that can have an s orbital? Where can we find the s orbital in our apartment? Level 1. So in level 1, we see the s. So the lowest energy level is the first energy level. There is already the s there. Next, what is the lowest energy level that can have a p orbital? Where does the p start in our apartment? 2. So second energy level. Number 9. What is the maximum number of electrons that a d sublevel can hold? D sublevel, how many boxes does a d sublevel have? How many orbitals? 5 orbitals. So therefore, the max number of electrons is 10. So because the question is about electrons, so 5 orbitals times 2, that will be 10 electrons. Number 10. How many orbitals are there in a d sublevel? 5 orbitals. Please make sure that you put the label 5 orbitals. Number 11. Which is the lowest energy level that has d orbitals? Where can you find the d? The first d. Floor number 3. So that will be the third energy level. Number 12. What is the maximum number of electrons that can occupy an f orbital?
14.
That will be 14. So 7 times 2, that's 14 electrons. Which is the lowest energy level having f orbitals? Where do you find the f? Where do you find the f? The first f is in 4th energy level. So that will be 4th energy level. Number 14. How many f orbitals are there in an f sublevel? There are 7 orbitals. 15. What sublevels are present in the third energy level? Third energy level. Sublevels are the letters. Sublevels. So S, P, and D. So that will be S, comma, P, comma, D. Then you put the word sublevels. Okay? Then you know already what is meant by electron configuration of the atom. What does it mean?
Arrangement.
The arrangement or the distribution. It can be arrangement or distribution of the electrons in the atom. Number 17. What is the maximum number of electrons that can be present in an atom having 3 principal energy levels? 3 principal energy levels, so that's third energy level. What's the number of electrons that can be there? That will be 18, correct. So that will be 18 electrons.
It says S electrons.
No, I'm sorry, that's not part here. What's the maximum number of electrons, okay? That's a typo error. I'm sorry for that.
Okay.
Number 18, how many sublevels are present in the second energy level, and what are they? Second floor, there are 2 sublevels. What are they? S and P. 2 sublevels, S and P. What is the total number of electrons in the second energy level? Second energy level, we have S and P. So we have 1 and 3, 2 times 2, 2 plus 6, 8 electrons. So we have 8 electrons. Okay? We're going to do number 20. I'll teach you number 20 on Friday.